So, hello. Today we see interference of waves. So, what is mean by interference wave means the combining of waves. The combining of waves with each other are is known as interference. So, but there is a two types of interference. There is two types of combination of waves are there. So, based on the types of combination. Uh, they classified into two types. First, we see what are the interference of waves means the combining of waves. Combining of waves is called interference. Combining of waves is known as interference. So there is two types of interference. The interference of waves is two types. So the first one is constructive interference. So constructive interference, first we see what is constructive interference means. For example, so this is a wave. This take it as a first wave. Okay. So this is a first wave. So next take another wave. Okay, we are taking the second wave. Okay, if the earlier we said what is interference? Interference means combining of waves. అయితే ఈ combine a type. For example, we know that this is the crest, this is the trough. Here also this is crest, this is trough. If a crest combined with crest, so for example దీని amplitude ఎంత అనుకుందాం, amplitude means okay, upper one take it as plus a. So downwards we know the depth is minus a. So the second wave is also having upper one plus a. Trough crest is having plus a amplitude. The trough is having minus a amplitude. We know that the minus symbol indicates just only about the direction, not about the value. Okay, it indicates about the direction. Plus a minus a. If their combination is like that to form a new perfect wave, అంటే ఈ టూ వేవ్స్ కంబైన్డ్ అయితే ద పర్ఫెక్ట్ బెస్ట్ పాసిబిలిటీ ఏంటంటే దెర్ ఈస్ ఎ ఫార్మేషన్ ఆఫ్ ఏ బిగ్ వేవ్. సో బిగ్ వేవ్ ఎప్పుడు ఫామ్ అవుతుంది? సో బిగ్ వేవ్ మీన్స్ మెయిన్లీ ఇన్ ద సైజ్. అన్నప్పుడు ఇక్కడ దిస్ క్రస్ట్ కంబైన్డ్ విత్ క్రెస్ట్ అండ్ ట్రఫ్ కంబైన్డ్ విత్ ట్రఫ్. సో క్రెస్ట్తో కంబైన్డ్ అవ్వాలి, ట్రఫ్తో కంబైన్డ్ అవ్వాలి. సో on this here it gives it must give a big wave. So how we are saying it is a big wave means so this is crest combined with crest, so plus a becomes 2a. The crest height is 2a. Next so again what is about the depth? So the trough of first wave combined with the trough of second wave becomes minus 2a. Means so there is a perfect combination. దీన్ని ఏమంటామంటే సూపర్ ఇంపోజింగ్ అంటాం. సూపర్ okay, superimposed means exactly perfectly combined crest with crest, trough with trough, and forming a big wave is called constructive interference. Okay, so this type of interference is called constructive interference and also known as superimposed interference. Okay, next what is the second type? In the second type means exactly opposite. Okay, afterwards we write the definition. destructive interference. Destructive interference means it is exactly opposite. So I will explain first. Say if you take a wave, this is the take it as a first wave. Let's take another wave. So already we know what are the points of a crest. So this is the crest with the plus A, it is with minus A. So this is also having, the crest is having a plus A, trough is having a minus A amplitude. So they combine like this. Already we said interference means combining of waves. So how they combine with each other means there is no final wave is obtained. Means finally the final wave low totally it loses its wave character. How it is possible means there is exactly the combination of crest with the trough of the wave, second wave. The trough of the first wave is combined with the crest of the second wave. So now finally there is a simple, we can it as we can draw it as like this only. So sometimes it is also taken very small one also, means total negligible of a wave character. So when it's possible means so there is a the combination of a crest with another trough becomes zero. So the trough of the first wave combined with the crest of the second wave total becomes zero. That's why it is also known as a single. It is also denoted with single wave. So single line. So it indicates that totally losing of its wave character. Total destroying takes place. That's why it is called destructive wavelength. So destructive interference. So generally in the experiments, for example, we have an experiment is to identify the structure of a crystal. Okay, sodium chloride. We know the many number of cesium chloride, different number of salt crystalline solids ఉన్నాయి. ఈ crystalline solids కి what type of structure find out చేయడానికి we have an experiment that's called Bragg's experiment. In the Bragg's experiment, what is the key point is the interference of the constructive interference of the X-rays. Constructive interference of the X-rays is a main key point in that experiments. Okay. Now we read the definitions, particular definitions, but you have to take these diagrams here only. So we read the definition. The interference in which crest of a wave combines with the crest and trough of a wave combined with the trough of another wave, finally forming a new big wave. The interference in which the crest of a wave combines with crest and the trough of a wave combines with the trough of another wave, finally forming a new big wave, is called constructive interference. Okay. Called constructive interference. So the diagram you have to take so already we discussed it. So now write the next point. So the interference in which, see the second definition. So the interference in which crest of the wave combines with the, so from here we change the definition, okay. Combines with the trough and trough of a wave, nothing but we can write the first one. A wave combines with the crest of another wave, the finally destroying the wave is called destructive. Is called destructive interference. So actually already just a few minutes later we given the diagram. You have to take that diagram compulsory. Okay. So constructive interference actually known as constructive is also known as, that is called in phase. Next, destructive is generally known as out of phase. So next, so here we see one more small definition. It is also having some calculations. That is electromagnetic radiation spectrum. Electromagnetic radiation spectrum means, so actually the word spectrum, the spectrum is mainly useful. Sorry, mainly it is a simple a picture. It is a picture indicating a, so something important, indicating something. It may be atomic spectrum is there, or it may be electromagnetic radiation spectrum. So it is a picture. It mainly explains about the wavelengths and frequencies of particular radiations. Okay. So what is electromagnetic radiation spectrum is, so already we know there is a different type of electromagnetic radiations are there. Just now we discussed in the last class, that is X-rays, gamma rays, cosmic rays, ultraviolet rays, radio waves, visible rays, microwaves. So they are different. So alpha rays, gamma rays, so alpha, beta not comes from the electromagnetic radiations. Only gamma rays comes from the electromagnetic radiation. If all these radiations, so what is difference in these all radiations and what is same in all these radiations? We know only one and only the property same in them is speed. Nothing but velocity of them is same, that is 3 into 10 power 8 meters per second, or 3 into 10 to power 10 centimeters per second. Next, remaining all other properties of characteristics of waves, that is they differ in their wavelength, they differ in their wave number, they differ in their frequency. So if all the electromagnetic radiations are arranged in the increasing order of their wavelength, in the increasing order of their wavelength, that arrangement simply, electromagnetic spectrum means there is a picture of arrangement of different wavelengths. ఇక ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్స్ మనం ఏ ఆర్డర్లో అరేంజ్ చేస్తామంటే సింపుల్ ఇంక్రీజింగ్ ఆర్డర్ ఆఫ్ దేర్ వేవ్ లెంత్. సో దట్ ఈస్ నోన్ యాజ్, దట్ అరేంజ్మెంట్ ఈస్ నోన్ యాజ్ electromagnetic radiation spectrum. So we can define that So the arrangement of different electromagnetic radiations in the increasing order of their wavelength. So actually, so దీనికంటే ముందు మనం రిలేషన్స్ హ్యావ్ టు డిస్కస్. బట్ ద ఇంటర్ఫిరెన్స్ టాపిక్ వెరీ స్మాల్ టాపిక్ ఉంది కాబట్టి ఇది యాడ్ చేసి చెప్తున్నాం. యాక్చువల్గా వేవ్ లెంత్కి ఫ్రీక్వెన్సీకి ఎట్లా ఉంటుందంటే ఎగ్జాక్ట్లీ రెసిప్రోకల్ టు ఈచ్ అదర్, మీన్స్ దే ఆర్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు ఈచ్ అదర్. సో ఇంక్రీజింగ్ ఆర్డర్ ఆఫ్ వేవ్ లెంత్ అంటే నథింగ్ బట్ decreasing order of their frequency. Both are equal frequency. That arrangement is called electromagnetic spectrum, or perfect word is electromagnetic radiation spectrum. So commonly we written as electromagnetic spectrum. Okay, so actually we have to remember this order. Okay, I will give the order now. The first, which are having the least wavelength. The least wavelength is gamma rays. So these are experimental. We have to remember. That's it. So next time comes for X-rays. Next ultraviolet rays. So next visible. So actually it is very small region. So visible region is a small region. It is a visible region. Next, infrared. IR means here full form is infrared. Next, microwaves. Next, FM radio. FM waves. Nothing but one more is there, AM. So both are actually belongs to radio waves. So generally we know that different type of radios now, that is 96.5, 93.5 something. So means what is that number indicates means సో అంటే మనకు ఒక్కొక్క రేడియో ఛానల్ ఒక్కొక్క నెంబర్ పైన వస్తుంది. సో ఆ నెంబర్ ఏంటంటే దట్ ఈస్ నథింగ్ బట్ ఎఫ్ఎం, దట్ ఈస్ కాల్డ్ ఫ్రీక్వెన్సీ మోడ్. ఒక్కొక్క ఫ్రీక్వెన్సీ మోడ్లో ఒక్కొక్క ఛానల్ వస్తుంది మనకి. నెక్స్ట్ నోన్ యాజ్ లాంగ్ రేడియో వేవ్స్. So this order, so in this order mainly we have to recognize. So you must remember this arrangement. Again important one. So we are able to see which type of radiations. Can you guess? Can you guess? We are able to see which type of radiation. Simply in the name itself it is there. That is visible. We are able to see the visible region only. That's why it is named as a visible region. So we are not at all see direct like gamma rays, X-rays, ultraviolet rays, infrared, microwaves, FM, nothing but radio waves, long radio waves. In all these type of electromagnetic radiation, simple we can observe directly to the visible region. So nothing but VGR. So again, visible region now there is a seven parts are there which we observe in a rainbow colors. Okay, that is known as VGR. Okay, there is a VGR colors. So what we have to remember is in that again VGR color which is having a more frequency, which is having a more wavelength. So already we know from left to right how they are arranged. What is electromagnetic radiation spectrum? So the arrangement of electromagnetic radiation in the increasing order of their wavelength. So increasing order of wavelength means from here to here, the left to right, the lambda value increases, wavelength increases. And in the definition we also give that from left to right frequency, from left to right frequency decreases, means which are having the highest wavelength long radio waves are having highest wavelength, which are having highest frequency, the gamma rays are having highest frequency. So actually we have to remember about this also. In the pictures all are we are able to see them. But violet is having high frequency, red is having highest wavelength. So generally we have a multiple choice question that in traffic signals generally they use red color. Why? So why they use red color means so red color ఏంటంటే సో మనకి ఎక్కువ డిస్టెన్స్ నుంచి కూడా ఈజీగా కనిపిస్తుంది కంపేర్ టు అదర్ కలర్స్. ఓకే, అన్ని డార్క్ కలర్స్ అయినా రెడ్ కలర్ మనకి పర్ఫెక్ట్లీ విజిబుల్ కాబట్టి ఎక్కువ డిస్టెన్స్ వచ్చే వాళ్ళకి కూడా పర్ఫెక్ట్గా కనిపించడానికి రెడ్ కలర్. సో ఇన్ టర్మ్స్ ఆఫ్ అవర్ ద subject we say the red color is having highest wavelength means we know that distance. So wavelength ఎక్కువ ఉంది కాబట్టి ఎక్కువ డిస్టెన్స్ కూడా అది విజిబుల్ అవుతుంది కాబట్టి ఇన్ ట్రాఫిక్ లైట్ దే యూజ్ రెడ్ లైట్. ఓకే, means here red is more wavelength. Okay, the color red, so it also appears very dominant. So red with more wavelength. So highest wavelength means not in all that, just we are discussing about in this VGR only. Next, what about violet? So violet is having highest frequency. Okay, so some values are also given there, but no need to by heart the exact values of them. But sometimes there is also some advanced questions are there in which we have to know what are the exact wavelength regions of a VGR. So for doing questions we have to remember this total order. Okay, so here I will give a very small information so about that for visible region. So visible region means nothing but visible rays, nothing but 7 colors, that is a VGR, where you observe these 7 colors in the rainbow have 7 colors. Okay, this is also known as white light. So this is having from wavelength approximate 3800 to 7600 angstroms. Next, the wavelength of infrared radiations. infrared regions are having a, the wavelength is approximately 7600 above, so there is a 10 power 6. So we know that so as time from left to right their values increases. Next, if you see ultraviolet light, ultraviolet light, for ultraviolet light it is somewhat less, there is approximately 1800 to 3800 angstroms. Means just to have to at least remember, so only types of radiations wavelength identification, but it's not an easy one and important, not important one. So visible region key left lobe, so nothing but left lobe means which are having lesser wavelength, that is ultraviolet having 1800 to 3800 angstroms. Next, visible region get the right side lobe. The right side lobe means having more wavelength, that is 7600 to 10 power 6 approximately. Okay, at least we have to remember this. Okay, so try to by had the electromagnetic radiation, the series. Okay,